All right, so we already know a few identities as far as trig goes, and we're going to look at some more today. So the first thing I want to remind you is that cosine is x. That's one of our identities. Sine is going to be y, so we want to make sure we have those written down. And then we've also already written down that tangent is sine divided by cosine. So the last one is a Pythagorean theorem identity, and you all know the Pythagorean theorem is that a squared plus b squared equals c squared. And what I want to show you is that a, if we look at this unit circle down here, a is going to be the x coordinate, and x we said was cosine, so this is cosine squared, or officially you're going to see like cosine theta squared written out right that, but I'm just going to shortcut that for us, all right? So cosine squared plus b is the y value, so that's sine squared, equals c squared, and c, notice the hypotenuse on this triangle, because it's a unit circle, is 1. So the fourth identity, I guess, that we're going to end up writing down is that cosine squared plus sine squared equals 1. When we go to solve some problems, there's some specific ways that that is more helpful. And that is to be, I guess, more specific. So notice these two gray boxes here. If we solve that for sine, so we're going to look here. If we subtract cosine from both sides, that's what they've done right here. They're subtracting cosine from both sides. We get sine squared equals 1 minus cosine squared. And then when we take the square root to get sine by itself, remember that leads us with two answers, plus and minus, and then the square root of this entire right-hand side. Cosine looks really similar when we solve. So this is just a shortcut for us. If you don't want to remember that, we can just solve this Pythagorean theorem identity every time. But it's obviously, if we can remember that shortcut, it's going to be a little quicker. So let's do two problems together. All right, so we're going to start similar to what we have done before. We're going to go ahead and name the quadrant that we're in and what we're looking for. So we're actually looking for cosine. So I'm going to go ahead and write down that we're looking for cosine, which is going to be an x value. I know that between 0 and pi over 2, that's going to leave me in quadrant 1. And in quadrant 1, the x values are positive. So I'm going to go ahead and set up my equation. I'm going to use these shortcuts rather than the original equation, just because they're not really that difficult to memorize. So I'm looking for cosine. So I'm going to say cosine of theta equals plus or minus the square root of 1 minus sine squared theta. And remember, I'm looking for the positive value. So here, I really only care about the plus sign. I don't care about the minus sign. So if I go ahead and plug my values in, then I'm just going to do cosine of theta equals, I want the positive version, so 1 minus sine squared. And sine squared, let me actually write this out. This is going to be 0.766 squared. And then I'm just typing that in exactly like I just wrote it. So my value, because this is not an exact value, I'm going to say that this is approximately 0.6428 is the approximate value of cosine theta. All right, let's look at one more example. Okay, this time they're asking us to find sine. So I know sine is going to be my y values. And I'm in the, let's see, we're going from pi to 3 pi. So this time I'm in quadrant 3. And in quadrant 3, I know the y values are negative. So I'm going to go ahead and set up my equation again. Sine of theta equals, I promise you it's not that hard to memorize, plus or minus square root 1 minus cosine squared of theta. And remember, this time I want the negative value, so I'm going to keep this minus sign down here. So I'm going to have sine of theta equals negative square root 1 minus cosine, and this time, I don't know why I keep writing that. This time I'm going to write negative 0.906 squared. So we're going to go ahead and work that out in my calculator. All right, and we want to make sure that you put parentheses in all of the same places that you wrote them. And when I type that in, I'm going to get, it's not an exact value, it's still approximately negative 0.423. All right, so that's going to be our approximate value for sine. Now this question 5 down here asks us the same idea, but it says supposing that instead of being in this quadrant 3, Now they're asking us to be in this other quadrant, which is going to be quadrant 4. Well, we know in quadrant 4, the y values, well, the y values are still negative. So how does this affect the value of sine? It doesn't. It's going to stay the same. So we're going to go ahead and write that out. In quadrant 4, y values, I spelled that wrong, are still negative. So sine would still be, the value would still be the same. So we can go ahead and write, so sine of theta would still be congruent to, or approximately, sorry, negative 0.423. The only time it would change if it had put us in quadrant 1 or in quadrant 2, that sine value would have become positive because we're talking about positive y values in those quadrants. All right, and I think that's pretty much all you need to know for the trig identities. So make sure you have good notes, and we'll wrap this up and finish this up tomorrow.